Hello everyone, welcome to my channel. Here we will discuss on manufacturing and services concepts with focus on productivity improvement. Some of you are just out from college and on the verge of stepping in the new world of man-machine methods and measurement. This channel is created to fill the gaps left behind between the college premises, classrooms, laboratories, and the shop floor with big machines running 24/7 with experienced technicians working. The factory floor of Shakti Auto Components in Pune buzzed with the steady rhythm of machines cutting, drilling, and shaping steel parts destined for automobile engines. Conveyor belts moved trays of half-finished components from one station to another, while operators checked gauges and recorded measurements. On her first day as a graduate trainee engineer, Ananya Sharma felt both excited and nervous. Fresh out of an engineering college in Nagpur, Ananya had studied industrial engineering and had recently discovered the principles of lean manufacturing. During her final semester project, she had read about improving flow and eliminating waste, but reading about lean in textbooks was very different from applying it on a real factory floor. Her supervisor, Mr. Kulkarni, gave her a simple assignment. "Observe the crankshaft bracket production line," he said. "We are struggling to meet customer demand. See if you can understand what is happening." Seeing the problem. Ananya spent her first few days simply watching. The line consisted of 6 processes: 1, cutting 2, drilling 3, milling 4, heat treatment 5, grinding 6. Final inspection. At first glance, everything seemed busy. Machines were running, operators were moving quickly, and stacks of components were everywhere. Yet something felt wrong. Despite all the activity, the final inspection station often ran out of parts while the drilling station had piles of trays waiting. The factory was producing less output than expected, even though every operator seemed fully occupied. This puzzled Ananya. During lunch, she remembered something her professor had said: "Lean starts with learning to see the flow." That evening, she began drawing a simple process diagram of the line using the concept of value stream mapping. What she discovered surprised her. Each part took only 3 minutes of actual processing time, but over 2 hours of waiting time between processes. Most of the production time was not work, it was waiting. Ananya returned to the shop floor the next day with a notebook. She carefully measured the time required for each process: cutting 40 seconds, drilling 120 seconds, milling 60 seconds, grinding 45 seconds. Immediately, she noticed a large imbalance. The drilling operation was much slower than the others. Because of this bottleneck, parts accumulated before drilling. Downstream processes often ran idle. Operators spent time moving trays instead of producing. This was a classic lean problem: uneven production flow. Ananya discussed her findings with Mr. Kulkarni. He smiled. "So you've discovered the bottleneck," he said. "Now what would lean suggest?" She remembered another principle from lean thinking: continuous improvement, known as Kaizen. Instead of large investments, lean encourages small improvements. Understanding the root cause. Rather than immediately proposing a solution, Ananya spent more time observing the drilling station. She noticed something interesting. Every time the operator completed a batch of parts, he had to: 1. Walk 5 meters to collect the next tray. 2. Adjust the fixture manually. 3. Change the drill bit alignment. These small activities added nearly 60 seconds to every cycle. The drilling machine itself was not slow. The setup and movement around the machine were slowing the process. Ananya approached the operator, Ramesh. "Can I ask you something?" she said. "Of course," he replied. She asked why the trays were stored so far away. Ramesh laughed. "That rack was installed years ago," he said. "Nobody thought about moving it." Sometimes the simplest problems hide in plain sight. Designing a lean solution. Ananya proposed 3 small changes. First, she suggested placing a small rack next to the drilling machine so parts would always be within reach. Second, she designed a simple fixture guide that reduced alignment time. Third, she recommended producing parts in smaller batches, allowing them to move through the line more frequently. The changes required almost no investment. The team implemented them during a weekend maintenance break. On Monday morning, they tested the new arrangement. Flow begins to improve. The results appeared almost immediately. Drilling cycle time dropped from 120 seconds to 70 seconds. The bottleneck began to disappear. Parts started moving smoothly between stations. Operators who had previously waited for parts were now continuously working. Within 2 weeks, production output increased by 35%. The factory could now meet its daily customer demand without overtime. Even more importantly, the shop floor looked calmer. Instead of piles of trays and confusion, components moved steadily along the line. Production had begun to flow. Learning to lead one. Afternoon, Mr. Kulkarni gathered the production team around the line. He pointed to Ananya. This improvement started with her observation, he said. Ananya felt slightly embarrassed by the attention, but the operator Ramesh spoke up. She didn't just give instructions, he said. She listened to us. That was an important lesson in lean leadership. A lean leader does not solve problems alone. They help the team see problems and solve them together. A new way of thinking. Over the next few months, Ananya continued working on other improvements, standardizing tool placement, reducing material movement, improving visual signals for production. Each change was small, but together they transformed the factory's performance. Workers began suggesting their own improvement ideas. The culture slowly shifted from working harder to working smarter. One evening, as Ananya walked across the shop floor, she noticed something different. There were fewer piles of inventory. Machines seemed synchronized. Operators communicated more easily. The production line had found its rhythm. The essence of lean. At the end of her trainee program, Mr. Kulkarni asked Ananya what she had learned. She thought for a moment. I learned that improving production flow isn't about machines, she said. It's about understanding the process, removing obstacles, and helping people improve their work. That insight captured the essence of lean thinking, not complicated theories, just the simple discipline of observing work, eliminating waste, and enabling continuous improvement. For Ananya, the journey had just begun, but she had already taken the first step toward becoming a lean leader. Lean is a continuous improvement process. Please like, share, and comment with your interesting questions. I will be happy to reply and try to clear your doubts. Your share and like would motivate me to create more such videos which are inherited from my 25 years of industrial experience.